Hello, class. Um, I hope everyone's doing well. If you haven't had a chance to check out my news announcement, you should probably take a look at that because it's got some important stuff in it. Um, Here, I'll show you. I'll show you Hazel. Hazel's sitting right next to me. There she is. She's sleeping. All right, so this should be a pretty quick, pretty easy lesson today. I'm trying to get the angle correct. So the first thing I wanted to talk about just really quickly are two really important facts in circuits. So two important facts. The first important fact is that things that are in series always have the same current. Things that are in series always have. The second important fact is that things that are in parallel always have the same voltage. Okay? So there's a nice mnemonic. Actually, it's a horrible mnemonic. It's to help you remember this. The mnemonic is SIPOV. All right? The mnemonic is so bad you won't be able to forget it. And so what it means is that series things have the same current. Remember, I is the variable for current. Parallel things have the same voltage. So in the next week and a half, basically until we go to spring break, I might say things like because SIPOV. And when I say that, I mean because series things have the same current and parallel things have the same voltage. Okay? So I hope everyone's got that. So today we're going to learn about a very important circuit, and it is called a voltage divider. Okay. So this is what a voltage divider looks like. So maybe we have a battery and it's a 100 volt battery or something. And it's connected to some resistors. There's nothing special about there being two resistors. There could be 3 resistors, 4 resistors, 5 resistors. Okay. So there's nothing special about that. Let's say that this is a maybe an 8 ohm resistor, and this is a 2 ohm resistor, something like that. Okay. So what we want to do first of all is we want to figure out how much current is going to flow out of the battery. Okay. And then really what we want to figure out is how much voltage do the 8 ohm and the 2 ohm resistors get. Okay, so different. This is a 100-volt battery, but that doesn't mean that every resistor gets 100 volts. I've said that to you before. Okay, so we're going to see how much voltage does each resistor get. Okay, so the first thing I'm going to do is I'm going to find the current that flows out of the battery using Ohm's law. Ohm's law says current is V over R, but I'm going to use the total resistance of this circuit, which it's a very simple series circuit. And so we just add those two resistances together and we get 10 ohms. So the current is going to be 100 volts divided by 10 ohms, which is 10 amps. So 10 amps is flowing out of the battery. Okay. But remember, this is a series circuit. Look at, you have the battery is in series with the 8 ohm resistor, which is in series with the 2 ohm resistor, and then it goes back to the battery. So everything is in series. So because of SIP of, the 8 ohm and the 2 ohm resistors each get 10 amps. So the 10 amps comes out, it flows around, and this one gets 10 amps, and this one gets 10 amps. You want to think about current almost like the flow of a river. Okay, if you have a river, you know, if this many gallons per second flows through the river, then that many gallons per second is going to flow through the river later on. Okay. All right. So here, notice we used Ohm's law for the circuit as a whole. But now we're going to use Ohm's law for a small part of the circuit. Okay. So we're going to use Ohm's law for the 8 ohm resistor. So if we do Ohm's law for the 8 ohm resistor, and that might be hard to see. This is for the 8 ohm resistor. Okay. It says V equals I times R. How much current does the 8 ohm resistor get? Well, we saw that it gets 10 amps. How much resistance does an 8 ohm resistor have? It has 8 ohms of resistance. That's pretty easy. So that means that the voltage this 8 ohm resistor gets is 10 times 8, which is 80 volts. 80 volts. Okay. I'm going to write that better. 80 volts. Okay. So now what if we do the 2 ohm resistor? Again, we're going to use V equals I times R. But now we're applying Ohm's law only to the 2 ohm resistor. Okay. Here we applied Ohm's law to the whole circuit. Here we applied Ohm's law to the 8 ohm resistor. And here we applied Ohm's law to the 2 ohm resistor. Okay. So we have the current that flows through the 2 ohm resistor is 10 amps, and the resistance of the 2 ohm resistor is 2 ohms. So that equals 20 volts. So what that means is that the 8 ohm resistor, if you were to hook up a voltmeter to the 8 ohm resistor, see how I'm putting it in parallel with the 8 ohm resistor, that would read if you hooked a voltmeter up to the 2 ohm resistor by putting it in parallel with the 2 ohm resistor, it would read 20 volts. Okay? 80 volts. The other observation I want to make is that the bigger resistor gets more voltage. Okay? So you can see that the 8 ohm resistor is hogging the voltage, if you will. Okay? So let me give you a little application of this circuit, and then we'll be done. This symbol right here, if I draw a resistor and I put a weird sort of like a line like that, that is called a thermistor, which is a temperature-dependent resistor. And the way that thermistors work, typically speaking, is that as the temperature goes up, the resistance of the thermistor goes down. Okay? Why is that? Well, it's because as you raise the temperature of something, you're causing the atoms to jiggle more quickly. And as the atoms are jiggling more quickly, they might eject an electron. So you have more electrons that are free to roam around in the wire, which means you have less resistance. Okay? Now, what if I built a voltage divider? Okay. So I build a voltage divider circuit where I have a resistor here, and then you have a thermistor over here. And so this part right here is sort of the probe. Okay, it's a probe, like a thermometer probe, right? Oops, I gave away what it is. It's a thermometer. This is a thermometer circuit. Sorry, I gave it away too early. And then we're gonna monitor. This is still a voltage divider, even though this wire bends, and it's also still a voltage divider, even though I'm putting a voltmeter in the circuit, because the voltmeter doesn't do anything to affect the flow of current. So I'm just monitoring that voltage, okay? So now let's say the temperature, and I'll call this R1 and R2 just for simplicity, okay? Suppose the temperature goes up, okay? Then that implies that R2 is going to go down. Now, since R2 goes down, that means, let's look at our observation here. The bigger resistor gets more voltage, right? So if R2 goes down, that means that it's getting less of its share of the voltage. It's getting less voltage. So in particular, because these two voltages have to add up to whatever the battery's voltage is, that means that the voltage across the first resistor is going to go up. So think about that for a second. I'll explain it again. If R2 goes down, it's going to get less of a share of the voltage, and R1 is going to get more of a share of the voltage. Okay? So let's look at this chain of logic. The temperature changes, and then the reading on a gauge changes. the temperature changes and the reading on a gauge changes. This is a thermometer. You would have to do some work to calibrate it, but this is a thermometer. And I challenge you to order the parts off Amazon and build one yourself. Excellent question. Does that mean if the temperature went down, it would be the opposite? Yes, it would be the opposite. Thank you, Layla. Now, here's the cool thing, is that really this could be anything. There are other devices, such as if I put wavy arrows going into the resistor, this is called a photoresistor, which is a resistor. We have a question, is R1 not fixed resistance? R1 is a fixed resistance. It's not a thermistor. It is a fixed resistance. But notice how in this example, okay, these have to add up to 100. Okay. There's a question. If we successfully document the construction of the thermometer, do we get extra credit? Yeah, I think I would give extra credit for that. So if this one stays fixed, but this one goes down, this is going to increase from 80. Okay. Anyways, a photoresistor is a light-sensitive resistor. So if you put a photoresistor in place there, you would have a circuit that is sensitive to light level. If you put a there's a thing called a strain gauge. I'm not sure what the symbol is for a strain gauge. But if you put a strain gauge in there, a strain gauge is sensitive to pressure. So if you put a strain gauge in place there, you would have a pressure-sensitive circuit, which would be basically a scale. So you can make an electronic scale. So I challenge you for extra credit to make one of these 3 devices. You can get all the parts on Amazon very cheaply, and have a wonderful day.